Number 15. If several pea plants with the genotype, we have big T, big Y, are crossed with the pea plants with the genotype big T, little y, what percentage of the offspring will be expected to have the big T, big Y allele combination? Okay, so this is obviously a dihybrid cross because we're looking at both T's and Y's. So because you have two sets of letters, it's going to be a dihybrid cross. So you're going to have two Punnett squares. So the first step that we always want to do is make sure that we're writing the parent genotypes. Okay, so the first parent, it told us, is right here. So we're going to rewrite that. Homozygous dominant T's and then heterozygous Ys. The second parent, right here, heterozygous T's and homozygous recessive Ys. Make sure that you're writing your letters where you can obviously tell the difference between a dominant and a recessive. So our next step is going to be our Punnett squares. Okay, so we're going to have two Punnett squares because we have two sets of letters, two traits. It's a dihybrid cross. And in our first Punnett square, we're going to use the T's. Okay, remember you never mix the letters. So we take the first parent who was homozygous dominant for T's, write his at the top. And then take mom's genotype, and she has heterozygous, so we write that on the side. And now that those are in place, we're going to go ahead and fill out the offspring genotypes in the middle. Okay, so remember you just move them over, move them down, rewrite them. So homozygous dominant, send this dominant T, this one down, so homozygous dominant. That one's heterozygous. Remember, you're always going to write the dominant letter first if you have one. And then last one, a dominant T and the recessive T. All right, now we can do our second Punnett square, and this one will be with our second trait, so with the Y's. The top, our first parent was heterozygous, and our second parent was homozygous recessive. Again, make sure you're writing to where you can tell the difference between dominant and recessive letters. Okay, and we solve for the offspring in the middle. Got a dominant and a recessive, so that one's heterozygous. Next one is homozygous recessive. One dominant, one recessive, so that one's heterozygous. And then last one, homozygous recessive. So now that we have all of that done, we need to go through and answer the final question, which is what percentage of the offspring will be expected to have this genotype? So homozygous dominant T's and heterozygous Ys. So we're going to do the T's first. You go and circle any of the offspring that are homozygous dominant for the T's. So here's one, here's another one, and we're going to write that fraction without reducing it. Next, we look at the Y's. We're looking for the heterozygous Y's. Circle them. Here's one, here's another one, and we write that fraction without reducing it. Remember, the last step of a dihybrid cross is always to multiply your fractions. If you don't multiply, you will always get the question wrong. So now we can multiply straight across. 2 times 2 is 4. 4 times 4 is 16. We can reduce that. 4 goes into 16 4 times, so it's 1/4. This question is asking specifically for a percentage, so 1/4 is equal into 25%. Think about quarters. Okay, if you have 1/4, that's 25 cents. So 25% is the answer, which was A.